Hello, welcome to this lecture video. I am teacher Melay. So this is the continuation of our lesson on normal distribution. So this is the same outline presented in other videos. So we are actually done with the first two topics, and the focus for this discussion is to discuss the standard scores and the normal curve and finding probability under the normal curve. So we are going to discuss the two last topics. Okay, so what is a standard score? So if the mean is equal to 0 and the standard deviation of 1, so we say that it is a standard score, or it is in a Z distribution. So it is also called the standard normal distribution, or Z distribution, or simply Z score. This is the formula for z-score. So what we actually need for us to compute for the z-score or the standardized score is the mean and the standard deviation. So there's no way for us to compute for the z-score if we do not have the value of the mean and the standard deviation. Okay, so let us consider examples for us to understand. So let us go here to answer some example problems. So in the given example, we will assume that all the distributions are normally distributed, because of course, if the data is not normally distributed, then it is also not possible for us to use the formula of the z-scores. So for problem number 1, you have a 90 grade in math and 90 grade in science. So if the mean grade in your math class is 85, with a standard deviation of 2, and the mean grade in your science is 87 with a standard deviation of 1. So convert your grades in z-score and determine where did you perform better. So the task here is to convert it into the z-scores and also to answer the question, where did you perform better if your scores in both subjects is the same, it is 90. Okay, so how to answer this question? So of course, we need the given. So we will compute for the value of that. Maybe we can make this smaller. So let us compute for the z-score for math. So the formula is, of course, x minus mean all over the standard deviation. The x here, or the score, is 90 minus, in the given problem, we identified that the mean is 85 and the standard deviation is 2. So it is 85 over 2. So this is 90 minus 85 is 5 over 2. So it is 2.5. Now for Z science, this is x minus mean also all over the standard deviation. So we have the same x or score. It is 90. But for science, it is given that this mean is 87 and the standard deviation is 1. So 90 less 87 over 1. So this will give you 3 over 1, or simply 3. So let us double check. 90 minus 87 over 3. So if we will plot this in our normal curve, so it means, of course, that the score of science is higher than the z-score than the 2.5. So this is science and this is math. So if we will answer the question, determine where did you perform better, since the z-score in science is higher than z-score in math, then you have better performance, or you performed better in science. So this is how we use standard z-score or standardized score. So what we did here is just simply to substitute the given to the formula and then compare which is higher. So the z-score in science or the z-score in mathematics. Okay, let us move to the next. Okay, next problem. So the average weight of the students in the physical education class is 55 kilograms with a standard deviation of 3. So if your weight is 50 kilograms, what is the z-score of this weight? So we are just simply tasked to convert weight into z-score. So z is equal to, again, x minus mean all over the standard deviation. X is equal to 50 kilos less the 55 all over 3. So it's a negative 5 over 3, and this will give you negative 1.67. So this is the standard deviation. This is the z-score of your weight, or of the student's weight, which is the 50 kilograms. Okay, let us move to a more challenging problem. So all students good in mathematics took the qualifying exam. So the passing score is 75. However, only the top 3 students will represent the school in an international math quiz B. Letter A. So if 50 students took the test, the average score is 80 with a standard deviation of 3. What is the probability of the students who obtained a score of 85 and above? Then letter B, how many students passed the test? Letter C, what is the score of the top 3 students? And letter D, what is the probability of the students who passed but did not qualify to represent the school? So let us answer this question. Let us answer this problem. Let's start with letter A. So if 50 students took the test, the average score is 80 with a standard deviation of 3. So what is the probability of the students who obtained a score of 85 and above? So for us to use also probability, which is the objective of our topic, the last topic in our outline, we need first to convert the given into the z-score. So in the letter A, so we are provided with the mean of 80 and the standard deviation of 3, and we are also provided with the score of 85. So for us to determine the probability, so we have to convert first the score 85. So z is equal to 85 less 80 over the standard deviation 3. So this is, what is 85 less 80? 5 over 3. So this is also 1.67. But of course, this is just the first step. We are not yet done answering the question, what is the probability? So we have to graph our problem. So 85 is located at the 1.67. So assuming that this is the 1.67. And it is 85 and above. So this is the shaded part. So how will we determine now the area of the shaded part? So we are actually done with our discussion. So in this problem, we will just apply how. So in doing this, we have to go back to our table because we need to check what is the area under the normal curve for z is equal to 1.67. So this is our table. So let us check what is 1.67 in our table. So 1.67. So it is 0.4525. Let's go back. So this is 0.45. Let's check it again. 4525. Okay. So what is the probability of the students who obtained a score of 85 and above? So what will we do to get the shaded region? So again, we know that the half of the curve is equal to 0.5. So what we will do is to deduct 0.5 less 0.4525. So this is 0.0475 equal to 0.0475. So what is the probability converted into percent? So 0.0475 times 100 is equal to 4.75%. So this is the final answer. So the probability is 4.75%. Letter B. How many students passed the test? So if let's go back to the problem. So the passing score is 75. So which means for us to determine how many students passed the test, we also need to convert 75 into z-score. So z is equal to 75 minus 80 over 3. So this is negative 5 over 3, negative 1.67. So if we will graph this, or rather we are going to draw the illustration. So this is the 1.67, negative 1.67. The shaded region is this region because it is, of course, the passing. This is where our 75 falls. So it is above, it is 75 and above. So we know that since it is again 1.67, similar with our letter A, so we know that from 0 to negative 1.67, the area is 0.4525. And we also know that half of the curve is equal to 0.5. So we will just simply add 0.5. So 0.9525. But we are not asked about the percentage, which is 0.95, or rather 95.25% of the students obtained a score of 75.80 or 95.25% of the students obtain a score of 75 and above, but we are asked how many students passed the test. So what will we do with 0.9525? So we know that the total number of students who took the test is 50. So which means we will multiply 0.9525 multiplied by 50. Let us double check if we have used the correct value. So 0.45, 0.4525. So we are going to multiply. So what is 0.45, or rather 0.9525 multiplied by 50. So it is a 47.625. But of course, we are talking about students. So we do not have a 0.625 students. So approximately there are 48 students who passed the test. Okay. So for letter A, our answer is, what is the probability? It is 4.75%. And then what is how many students passed the test? So how many students? There are 48 students. Let us copy this problem in another sheet. Okay, and then let's move to problem C. What is the score of the top 3 students? So for us to determine first what is the score of the top 3 students, we need to know. So of course, we have to illustrate this using our normal curve. So we know that the top 3 is of course located in the upper tail. So this is the shaded part. But for us to know what is the score, we need first to get for the proportion or area. So what is the area here? So let us compute. So what is 3 all over, what is 3 all over 50? So it is 0.06, so it is 0.06 or 6%. So if this is 6% or 0.06, then it means that this is 0.44. So if our value here is 0.06, so it means that from 0 to the z, which is not yet defined, is 0.04. So how will we know what is the value of C? So remember that when we are trying to figure out what is the area, the process that we use is for us to go back to the table that shows the areas under the normal curve. So we are going to reverse that procedure by also looking at the table, but right now, instead of using the area, or instead of using the z-score to obtain the area, we will use the area to obtain the z-scores. So let's go back here. So let's locate 0.44 area. So we know that, of course, our area is located at the center. So where is 0.44 located? So we have here option to choose whether it is 0.4394, so which is, of course, we cannot find here for an exact 0.44. So which is near to 0.44, it's a 0.4934 and 0.4406. So how will we determine what z-score for this area will we choose? So to do that, so let us just check first. So let us consider 0.4394 and the other one is 0.4406. So we are going to deduct 0.44 to these values. So what is 0.44? To determine which is near to 0.44. So 0.44 less 0.4406. So for the first one, this is 0.00006. So for the second one, it is 0.006 also. So we actually have the same distance. So we can use either of the two. So if we opted to use the first one, anyway, the difference or the distance from 0.44 is also 0.006. Then we can use either of the two z-scores with this area. Okay, so let's go back. Let us remove this first. So what is the z-score for 0.4334? So let us locate. It is 1 point, if we will use this, it is 1.55. So the z-score is 1.55. So the z-score here is 1.55. The z-score for 0.44 is 1.56, but we will use the first one. So next, we already know that z here is 1.55. Let's double check. It's 1.55. Okay, so now, since we obtained the value of the z, can we convert this into the raw data for the actual score? So using the formula, z is equal to x minus mean all over the standard deviation. So we can actually substitute the value of z, which is 1.55. So let us remove the equal sign. 1.55 is equal to, what is our x? X is the 80. Sorry, we do not know the value of x. So that is what we are trying to solve. So x less 80, this is the mean all over the standard deviation 3. So we will compute 1.55 multiplied by 3. If we will transpose this, plus 80 is equal to x. So this is just simple algebra. So we multiplied both sides by 1/3 so that the 3 here will be removed. So 1.53 times 1. We multiply both sides by 3. So 3 all over 3 is 1. So this will be canceled. That's why we have 1.55 times 3. Plus, we add plus 80 to both sides of our equation. That's why negative 80 here was again canceled because negative plus 80 is equal to 0. So that is what we do. So it is just multiplying by 3 and then adding both sides by 80. So what is 1.55 times 3 plus 80? So let us check. 1.55 times 3 plus 80 is 84.65. So x is equal to 84.65, or this is 85. So which means that what is the score of the top 3? The score is at least 85 or 85 and above. So this is the score of the students. And then, what is the probability? So let us move to problem letter D. So let us again select this. What is the probability of the students who passed but did not qualify? So remember that we have a problem here that asks for the question, how many students passed? That is letter B. So going back to our answer to letter B, the answer for letter B is 48 students. And how many students qualify? It is the top 3. So there are 30, there are 3 students. So for letter D, if there are 48 students who pass the test based on our computation in letter B, and there are 3 students who are qualified, then it means that there are 45 students who passed but did not qualify. But the question here is probability. So it is 45 all over 50 times 100%. So just to show you, so 45 all over 50 times 100 is equal to 90. So there are 90% of the students who passed but did not qualify to represent the school. So this is all for this video. Thank you for watching.